Today we're going to be looking at a simple guide to calculating percentages.
We're going to look at finding 10% first and then applying that to some problems. Then look at 1%, also applying to some problems. Then we're going to take it a step further. So this might be useful for year 5, 6s or advanced year 4. We're then going to go through 50%, 25% and 75%, followed by more complicated percentages. If you want to do some activities, please look in the comments and there are links pointing you in the right direction.
We're going to start by learning how to find 10%. And to find 10%, we do one simple thing, and that is to divide by 10. Now, dividing by 10 is a skill which we can start learning in year 3. But it's also a skill that even in year 6, I see children who don't have secure strategies. So I'm going to just demonstrate the concept of dividing by 10 using a place value chart, some place value counters, and I'm also going to write the digits on a place value chart. So I'm going to start with just a 2-digit number. So I'm going to start with the number 30, and I'm going to pop that on my place value chart using place value counters. So you can see that I have 3 counters in my 30 section. That represents 30. Now, if I was to write that, it would look like this. So I have 3 counters in my tens column with nothing in my ones, or I have the number 30. Now, to divide by 10, when you divide, it gets smaller. So when you divide by 10, each digit in your number decreases. So it's going to have a lower value. So 3 counters that were in the tens column now move to the ones column. However, they're worth 10, so I'm going to swap them for 3 ones. So I had 3 counters in my tens column, and I simply move them to my ones column. If I take my digits, I'm going to move each one over. So my no ones moves over to no tenths, and 3 tens moves over to 3 ones. Now this 3 at the bottom, I need to remember to put my decimal point in here. But 3.0 is the same as just 3. Okay, let's have a look at doing that with another number. This time I'm going to choose a 3-digit number. So I'm going to choose the number 340. So I have 3 counters in my 100, 4 counters in my 10, and if I was to write it, 340. Now to divide it by 10, I do exactly the same thing. I'm going to take my 4 counters in my tens column and move them over, but they now need to swap for 4 ones. And my 300s need to move over. And again, they need to be swapped. So I'm going to have 3 counters in my tens column. Now with my digits, I'm going to move each one over. Now, once you've got something in your ones column, if there's nothing after it, there's nothing in the tenths, we can actually get rid of that. So my answer is 34 in both cases. So I'm going to take the number 500, I'm going to write it in. To divide by 100, we're going to move 2 spaces. So I'm going to take each of my counters and they need to move 2 spaces. So my 500s now need to be swapped for 5 ones counters. Let's take my digits and they also move over 2 spaces.
anything after the ones isn't needed. If it's all zeros afterwards, it's not needed. So that becomes a 5. This time I've got 700. If I divide by 100, if I find 1%, again, I'm going to take each digit in my number and move it 2 spaces. So we're going to move over 1 and 2. I have 7 counters here and swap those for 7 ones. So looking at my digit, I'm going to do each one separately this time. 1, 2. Finally my 7, 1, 2. And in both cases I have 7. Let's look at a problem where we have to subtract 1%. 1% of a cup of 300 millilitres of water is spilt. How much water is left? So we need to first of all find out what 1% of 300 is. So we can use our counters, or we can write our digit in. And we're finding 1%, so we're going to move each digit over 2 spaces. 1, 2. This is something that eventually you'll do mentally, because you'll be able to visualize each digit in your number sort of moving. You'll be able to visualize 300 now becomes 3 tens, becomes 3 ones. So using this and letting your child look at the chart will breed that familiarity, and eventually they should be able to visualize that, and that's then how we build our mental calculation skills. So using the numbers 2, don't need that, 1, 2, it's 3. So 1% of 300 millilitres is 3. So we're now doing 300 take away 3, which was our 1%. So I'm going to write in, there's my 300. Let's look at how to subtract 3 using place value counters and the concept of place value chart. So I need to take away 3 ones. If I look in my ones column, there is nothing here. There's no 3 ones to even take away. So I need to see if I can borrow some from here, exchange any tens. There's no tens either, no tens. So I'm going to go to my hundreds now, and I have things in my hundreds column. So I'm going to exchange. I'm going to take 1 counter and swap it for 10 ones. I can now lend something to my 1 section. I'm going to take 1 10 counter and change it for 10 ones. I now am able to subtract that 3. So I need to take 3 ones away, and I take those away. If I now write what I've got in each column, I have 2 in my hundreds column, I have 9 10 counters, and I have 7 ones. So my answer is 297. Let's take a look at how we do that using a formal written method. I can't do 0 take away 3. I need to pop to my neighbour to borrow. I've got nothing there either. I need to pop over to the next neighbour. So I'm going to borrow 1 from there. That becomes a 2. Now I commonly see the 1 skipping the 10 and going here. So we need to make sure that we lend to our tens column first. Then cross that out, leave that as a 9, then exchange it here. So we now have 10 take away 3 is 7. 9 take away nothing is still 9. 2 take away nothing is still 2. So the answer is I have 297 millilitres left. Okay, so we're going to take it a step further now. What if I ended up with a decimal answer? So for example, if I wanted to find 10% of 32, I need to remember that each digit is just going to move over 1 space. 10%, it moves 1 space because I divide by 10. So each of my 2 counters in my ones column will move over. They'll now be worth a 1/10. So I'm going to swap those for 2 tenths counters.
and my 3 tens will become 3 ones. If I show you with my digits, each will move over one space, and I need to remember that there is a decimal space here. So 10% of 32 is 3.2. Let's look with another example. Let's look at 10% of 521. We're dividing by 10 because 10% is divided by 10. So each of our counters moves along and then gets swapped down. Now you don't need to use place value counters. You can just use normal counters, objects, whatever you can find, cubes, Lego. But 2 in the tens column is now worth 2 in the ones column. My 5 in my hundreds column is now worth 5 in my tens column. And with my digits, each one moves along one place. So I'm going to move the whole number over together. Remembering anything after the 1 needs a decimal point. So 10% of 521 is 52.1. Let's now look at finding 1% of 270. So I'm going to write my digit at the bottom. If I find 1%, I need to divide by 100. If I divide by 100, I need to move everything over by 2 spaces. So my 7 counters in my tens column, they're all 7 counters are going to move over to my ones column. Now I'm going to swap them with 7 ones. And my 2 counters in my hundreds column are going to move my 7 counters in my tens column need to move 2 spaces. 1, 2. So I now need to swap these 7 tens counters for 7 tenths counters. And my 200 counters need to move 2 spaces, 1, 2, and I need to now swap those with 2 ones counters. If I look at my digits, each digit needs to move over 2 spaces, 1, 2, that will actually go in the hundredths column. This place value chart does go on and on to the hundredths, the thousandths. You could keep going on. You only need to know up to 3 decimal places by the end of year 6. For now, tenths is fine. So I move my hundreds over 2 columns. I need to put my decimal point in, and I have 2 and I have 7 tenths. 2.7 is the same as saying 2 and 7 tenths. Let's look at solving a problem using 1%. 1% of 450 grams of flour was spilt. How much flour was left? Okay, so the first thing we're going to do is find our 1% of 450. So first of all, make sure we've got 450 in our place value chart. So I have 450. And next I find 1% by dividing by 100, which means I move every counter over 2 spaces. So my 5 counters in my tens column moves over 2 spaces. I need to swap that now for 5 tenths column counters. And my 4 counters in my hundreds column need to move over 2 spaces. So let's watch 1, 2. I need to swap that for 4 ones counters. And if I do the same in my digits, 1, 1, 2, 1, 2 becomes 4.5. So now that I know it's 4.5, I can subtract. So the calculation I'm doing is 450 subtract 4.5. So we always start with our smallest digit. So we want to take away 0.5 or 5/10. I can clearly see there's nothing in my tenths column. So I need to go over to my ones column to see if I can borrow and exchange, which I can't. So I'm going to go over to my tens column and I'm going to take one of my tens and swap it for 10 ones. I'm now going to take one of my ones and I'm going to swap that for 10 tenths. I'm now able to subtract my 5/10 from my tenths column. 5/10 gone. And now I can subtract the 4 from my ones column and I'm left with my answer. I have still got 400. I've now got 40, 4 tens. I've now got 5 in my ones column and I've now got 5 in my tenths column. Important to remember the decimal point. So my answer is 445.5. Let's look at that with a written method. So this is a formal written method. Now the most important thing to do here when you're subtracting numbers and they have different decimal places is to give them the same decimal places. So I would put a decimal point in there and just pop a 0 on top rather than leaving it empty. So we're starting at the smallest part of the number at the tenths column. I can't do 0 take away 5. I go to my 0, I can't borrow from there. I go to my 5s, cross it out, that becomes a 4, and I lend it here. Then I can borrow, remembering to write that as a 9 before I pop my 1 here. 10 take away 5 is 5, put my decimal point in. 9 take away 4 is 5, 4 take away nothing is 4, and 4 take away nothing is 4. So there is 445.5 millilitres left. Okay, now we're going to look at 50%. Now 50% is the same as a half. To find 50%, you simply divide by 2. So let's take the number 48. 50% of 48. Now you need to be able to divide it by 2. Some of you will be able to do it mentally. Some of you might just do a bus stop like this. 2 into 4 goes twice, 2 into 8 goes 4. That's often quite an easy way to do it. I see a lot of children doing it like that. That's fine. 50% of 48 is 24. Or some of you might visualize your 48. So if I show you what I mean. So you've got your 48 and you're just going to divide both the 40 and the 8 into 2 piles, to 2 groups. And there you have 24 in the top group and 24 in the bottom group. Now that is all fine when you are finding half of an even number, but when you're finding half of an odd number, I'm going to show you a different method. Okay, so if you were finding 50% of the number 29, for example, which is an odd number, you could do bus stop. If you're not sure how to change your remainder into a decimal, you'll get stuck. Okay, so you do need to know how to convert a remainder to a decimal in year 5 and year 6, but there's no reason why in year 3 or 4 you can't have strategies of how to halve an odd number. So if I take my number 29 again, I like to partition it. So I know that my 29 is made up of 20 and 9. We've shown that with our place value counters. You might even want to use your place value counters. I like to do this and separately divide them. So my 20, I can halve that into 10 and 10. My 9 though, if you might know what half of 9 is, but if you don't, what you can do is separate it into an even number plus 1. My 8, I'm going to halve because it's an even number. And all you need to remember is that half of 1 is 0.5. If you just remember that half of 1 is 0.5, then you can halve any odd number. And then now I just need to take half of every number. So I've got my 10 and my 4 and my 0.5. So half of 29 is 14.5 if I add all those together. Let's do it with a bigger number. Let's say I'm finding 50% of 137. So I can partition this into 130 and 7. So my 100 is relatively simple. That's 50 plus 50. Done. My 30, if you're not sure how to halve 30, similar to the odd number, the odd single number, I can separate it into 20 and 10. Half of 20 is 10 and half of 10 is 5. Then my 7, if I don't know what half of 7 is, then if I find the even number before it and then add 1, half of 6 is 3, half of 1 is 0.5. So half of every digit, I've got 50 and 10 and 5 and 3 and 0.5. So that's 50, 60, 65, 68, 68.5. Obviously you could write it out and add it up. Don't have to do it in your head like I did. That's how you find 50%. Let's look at 75% next. Let's look at 25% next. 25% is the same as a quarter. Good fact to remember. To find 25%, you could either halve, then halve again, or you can divide by 4. So let's take the number 80. I could divide by 4 using a bus stop. 4 into 8 goes 2, 4 doesn't go into 0. Or I could halve and halve again. So half of 80 is 40 and half of 40 is 20. Let's take the number 296. If I had to find 25%, I can either divide by 4 or I can halve it as we did before. So 96 is 90 and 6. Half of 90 I can separate into 80 and 10. And add all those up. So half of 96 is 48. So I'm going to write that there. And then I can halve my 48. 40 and 8. Half of 40 is 20. Half of 8 is 4. So my answer is 24. Either way I do it. Do the way that suits you. So to find 25%, you simply divide by 4 or halve, then halve again. Let's look at finding 75%. So to find 75%, you find 50% and add 25%. Or you could also find 25% and subtract it. So for example, if we take 96 again, earlier on we found 50% because we halved it. So 50% was 48. We've just done this on the slide previously. And 25%, which is half of your 50%, was 24. Well, 75% is just these two added together, isn't it? So the answer will also be these two added together. So it's 82. Let's take another example. Let's take the number 294. So to find half of it, I'm going to find half of my 200, which is 100, half of my 90 by finding half of 80 and 10, and then half of my 4, So I've got 147. So 50% equals 147. So now I need to find half of my 147. Remember, use the bus stop method if you're able to, because that is quicker, or you might actually just be able to do it mentally, but I want to help you build up strategies. So half of 147 now. Half of my 100 is 50. Half of my 40 is 20. Half of my 7, I can do 6 plus 1. Half of my 6 is 3. And remember that half of 1 is 0.5. So we need to add these up. 50, 70, 73, 73.5. That's my 25%. So 75% is simply 25% and 50% added. So I've got to add these. So I might need to write it down, remembering to line up my digits and fill in any empty gaps. 0 plus 5 is 5, 7 plus 3 is 10, 4 plus 7 plus 1 is 12, and 1 plus 1 is 2. So my answer is 220.5. So remember, you can pause, you can go back. There's some strategies to find lots of different percentages. Now, if you'd like to, pause the video and see if you can have a go at this activity. Can you put the values in order from smallest to biggest? I'm going to show you now how to find some more complex percentages using easier facts. So I like to make a bit of a spider diagram. So for example, in the middle I have 150 and I've written in what 10% and what 50% is. Now using just 50% and 10%, you can find loads of other percentage facts. So for example, if I know that 10% is 15, 5% is going to be half of my 10%. 5 is half of 10, so my answer here is going to be half of this. And half of 15 is 7.5. You can also see a link between 5% and 50%. 5 is 10 times smaller than 50, and 7.5 is 10 times smaller than 75. Let's look at my 20%. 20 is double 10, so my answer is going to be double my answer for 10. And double 15 is 30. Are you starting to see a pattern here? If I move along to 40%, well, 40% is double 20%. So my answer is going to be double. Now, if you want to have a go at this problem now, pause the video now, give it a go, and then you can unpause and then you can check it against the answers I'm doing. So I'm now going to go to 15% and I can actually add my 10 and 15% together. So 15 and 7.5 is 22.5. Now down to my 30%, I can add, well, I could either multiply my 10% by 3, so do 15 times 3, or I could add my 10 and my 20% together. So 15 and 30 is 45. And from my 30 to 60, I can double it. 45 times 2 is 90. Let's go the other direction. We've just done 25% and 75%. So this time we want to find half of 75. So half of 75 is 37.5. And to find 75%, we want to add 50 and 25% together. So to add those both together, I could do 75 and 30 is 105, plus 7 is 112, plus the 0.5 is 0.5. Let's go to 1%. Remember, 1% is dividing by 100. All these percentages, just to remind you, are of 150. Okay, so we're finding 1% of 150, but I can use my 10% to help me because I can either divide straight from 150, divide it by 100, or I can divide it by 10, then divide it by 10 again. So 150 divided by 100 is 1.5, and I can see that 15 divided by 10 is 1.5, so that works. Finding 2% is simply doubling my 1%. 1.5 and 1.5 is 3. And let's check 2% and 20%. 3 and 30. Can you start to see the link here? Okay, using that, 3% and 30%, how would they link? Okay, so I might see the link there. I might divide this answer by 10, or I might add my 1% and 2% to get 4.5. Don't put a percentage here. I do see lots of people doing that in their answer. The percentage is the question. The answer is a number without a percentage. So don't put a percentage in your answer. Common mistake. 4%, you could either multiply your 1% by 4, or you could multiply your 2% by 2. Either way, it's a 6. Okay. Hopefully you've learned some methods for percentages. There are tons more things I could say about percentages, but if you would like to learn more, there are more lessons, activities, past SATs, questions, etc. on percentages in the Pocket Private Tutor app. Just search the app stores or go to the Pocket Private Tutor website, and you'll be able to look in the ratio section, and there is a calculating percentages section there. In the fraction section, there are a few lessons on equivalence between fractions, decimals, and percentages. Lots of things on percentages in the Year 6 curriculum. Lots of things you'll need to learn about percentages in secondary school. You'll start learning about simple interest, compound interest, reverse percentages. So it is something that you need to learn. Regardless of whether SATs is on or not now, percentages is one of the things you'll need to really know going forward in your education, but also in the real world. All the shops always have lots of sales. It's really good if you can mentally calculate what the best deal is, because you're able to use percentages. Check out the links in the comments. There's some free percentage questions, activities, so you can put your skills to practice. There's lots of links to Twinkle. I've also put a link to a quiz on Kahoot that I've done. All you need to do is put into Google Kahoot login or Kahoot play game. You shouldn't need to log in or create an account or anything, but you'll need the game pin, which I've also put in the comments, so you can have a go at an interactive quiz, which means you don't really need to do any jotting down or any printing of paper. Okay, hope you enjoyed the lesson. Hope you've learnt something today.